Okay, so now let's go on to number 6. Too many papers here. Okay, example 6 says determine whether the probabilities are independent. Now we're going to use the other formula. For each pair of probabilities, determine whether E and F are independent. So on this one, it says we toss a coin 3 times and record the sequence of heads and tails. E represents at most 1 heads occurs, and F says both heads, or both at least you got heads and tails, so it's a mixture. You can't have everything, all one thing. So I'm going to use this formula here. So this is what it looks like. Okay, there's my formula. So the probability of E times the probability of F is equals probably E and F. So what we're going to do is plug our numbers into that to see if it works out. So E represents at most 1 heads. Now what I did here is we're tossing the coin 3 times. Here's all the possibilities. There's going to be 8 of them altogether. I could get heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. I could have used a tree diagram to get those. So E says at most 1 head. So when you look at these, at most, that's got 3, that doesn't work. That's got 2, it doesn't work. That's got 2, it doesn't work. But this guy does. I got at most 1 head. That's got 2, so that doesn't work. This one does, and this one does, and that one, well, that one would too. At most, it could be 0. So that's 4 out of the 8, or in lowest terms, that's going to be 1/2. Okay, F says both heads and tails occur. So again, if you go back to these, both heads and tails, that's a no, because there's no tails. That one works. 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 That one does not. That doesn't have any heads. That did not have any tails. That didn't have any heads. So those 2 did not work. Add them up, they're 6. So that's 6 out of the 8, which is 3/4. Okay, and then what about the probability of E and F? So E and F, so you got at most 1 heads. That one doesn't work. That one doesn't work. That one doesn't work. Does this one? Is there a mixture of heads and tails and at most 1 heads? Yes. Put an asterisk out there. So that one works. This one does not because you got 2 heads. This one does. You got 1 head, you got tails. There you got 1 head with some tails. Okay. This one satisfies the first one, E, but does not satisfy the second. So that's going to be 3/8. That's where I got those from. Okay, so now that you got those probabilities, now we're going to plug into the formula and see if it works. So the probability of E was 1/2. Probability of F is 3/4. And E and F is 3/8. So if I multiply those 2 together, you do get 3/8. So 3/8, yes, that's equal. So yes, you can say they are independent of each other. That means when one of them happens, that doesn't affect the other one. Okay, so just real quick going back, I've given you some formulas here. And I'm showing you could use either one of those. And by the way, if you'll remember this, I could have a P, the probability over the probability, or I could have N, which means the number. Either one works here. But that's basically all the same formula as far as I'm concerned. So you got this one, or you got this one. Sometimes it's easier to use one rather than the other. It doesn't matter to me. As long as it satisfies one of those formulas, then they're going to be independent. Okay, so let's look at 6b. 6b, this is the last one we're going to do. Now we got a family of 4 children. E represents at most 1 boy, and F represents at least 1 child of each gender. Okay, so let's see what I did. First thing I did is I came up with all the possibilities. So there's 4 children. You can have 4 boys. You can have 3 boys, then a girl. Here you can have boy, boy, a girl, and then a boy. You can have boy, boy, girl, girl, and you go all the way through that. There's going to be 16 of those altogether. Okay, so the first thing is the probability of E. At most 1 boy. Okay, at most 1 boy. So that one does not work, sorry. That one doesn't work, 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 this one does. That's the first one where you've only got 1 boy. You can have 1 boy or less. That doesn't work, that doesn't work, that doesn't work, this one does. That doesn't work, this one does, this one does, and this one does. So if you count them up, that gives you 5 out of 16. The next one says that at least 1 child of each gender. That one doesn't work because they're all boys. But all the others do except for the last one. See, I got all girls. You got to have 1 of each, so that doesn't work. This doesn't work because you had all boys. So when you look at that's 14 out of 16, which is 7 over 8. Okay, and then E and F. So now you got at most 1 boy, and you got to have some of each. Okay, so that one didn't work. That one doesn't 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 work. Actually, I could just use these over here. Does this one work? You got at most 1 boy and you got some of each. I'm going to circle it. That one works. The next one we look at is this one. This works because you got some of each. This one works because you got some of each. This one works because you got some of each. This one does not work. So when you count them up, I got 1, 2, 3, 4. So the probability of both conditions holding, that's 4 over 16, in lowest terms 1/4. Now plug it in your formula, and you're going to ask yourself, is that true? So the probability of E was 5 over 16, that was up at the top. Probability of F was 7 over 8, and the probability of both is 1/4. So we multiply those. On the left, you get 35 over 128. Is that equal to 1/4? Well, even now, I'm not sure if you would know that's true or not. At this point, if you didn't know better, I would change them to decimals. This 35 over 128 works out to be 0.2734. And of course, 1/4 is 0.25. I put 0, 0. Are those equal? No. That means E and F are not independent. Okay. There's a lot more in that chapter you can read, but I don't think you need to. You're probably going to get confused the more you read. But that takes care of everything I think you need to know about independent. Okay, that takes care of chapter 6.